circuit diagram and how a Zener diode voltage regulator works with varying input voltage and varying load resistance. Now all we have to do is to supply sinusoidal edge here. It will go to the primary winding of transformer. Here you will see the secondary winding. Okay, this one is a transformer, this one is a symbol, this one is a transformer. Okay, now here this one is A terminal, say this one is B terminal. Now it will travel to a Wheatstone bridge circuit of a diode. Okay, I will draw here Wheatstone bridge circuit of a diode. Now here we will insert a diode, say, okay, this one is another diode. Look, okay, this one is another diode, this one is another diode, and finally this one is another diode. Provide name to the diodes. I will say D1, I will say D4, Li D2, okay, and this one is D3. Okay, I'll provide it that. Now it will be a connection of, now it will go. Now here you can see the capacitor, one capacitor, and now here will be a inductor. Okay, and now a resistor, another capacitor in parallel connection. I will give it a name, it is C3, this one is C2. Okay, now it will go like this, and now here you will see a Zener diode, and finally here you can see here this one is a load resistor, and there it will provide you finally a DC voltage. Okay, this one are for the DC voltages. It isn't clear. This one is a RL resistor. Okay, this one is a resistor, this one is a RL resistor, this one is a Zener diode. Okay, now this one is a, this is filter circuit. Okay, this one is a filter circuit, and now this one is regulator. Okay, this one is a regulator. Now this one is a transformer, this is a Wheatstone bridge circuit, that is, this is a bridge rectifier with 4 diodes, you can see with their connection. This one is a filter circuit, this one is a regulator, I have talked it early. Now for the regulation with the varying, regulation with varying input voltage. Okay, varying input voltage for conduction, for the regulation with a varying input voltage, when the input voltage increases, the input increases also in, okay, the input current also increases. Let's see I. Okay, that means when the input voltage B increases, the input current I also increases. It is based upon the Ohm's law. This increases the current through the Zener diode. Okay, that means current through the Zener diode, that is IZ. Okay, current through the Zener diode, this one is a Zener diode. Okay, this one is IZ also increases without affecting the load current IL. Okay, load current IL. Okay, so the increase in the input current will also increase the voltage drop across the series resistance RS also. Okay, series resistance RS, thereby keeping the load voltage as constant. On the other hand, for basic purposes, if the input voltage is decreased, okay, this input voltage, if it is decreased, the input current also decreases. As a result of this, the current through the Zener diode will also decreases. Consequently, the voltage drop across series resistance will be reduced. Thus, the voltage BL and load current IL will always remains constant. That is, the voltage drop across series resistance will be reduced the voltage VL and load current remains constant. That is, it is working as a voltage regulator. That is the operating principle when we talk about the principle based upon the regulation with the varying input voltage. Now, if we talk about the load phenomenon, that is regulation with varying the load resistance. Okay, regulation with varying load resistance. This one is one method working as a voltage regulator, that is varying with input voltage. Now this one is based upon the load resistance. When the load resistance RL decreases, the load current IL will get increased. This causes the Zener current to decrease because a Zener diode is a properly doped crystal diode having the sharp breakdown voltage. If you talk about the Zener diode, it has a property like this. Okay, this one is a VI characteristics of the Zener diode. If you take here I, okay, and this one is a IZ, this one is a P, this one is a VZ. Okay, now there you can see the knee voltage. This is based upon the, it is the phenomenon based upon the biasing purposes. Anyway, when the load resistance RL decreases, the load current IL increases. This causes the Zener current to decrease. As a result of this, consequently the input current and the voltage drop across the series resistance remains always constant. Thus the voltage BL is also constant. Okay, that means the load voltage is always. As a result of this, the input current and the voltage drop across the series resistance will remain constant. Thus the voltage BL is also constant. On the other hand, if the load resistance increases, that is, if you increase the load resistances, the load current will decrease. As a result of this, the Zener current increases. This again keeps the value of input current and voltage drop across this type of series resistance as constant. Thus the voltage will always remain constant, and this circuit will act as a voltage regulator based on the regulation with varying load resistor. Now I will illustrate it or the purpose of the voltage regulator by connecting a simple LED strip. Okay, I will proceed it now.